Good. Hi, everyone. Let's wait for the screen to catch up. Because, all right, beautiful. Hello, everyone. Hope you're enjoying Decipher. I'm Alessandro Capellato Ferrari, Head of Product at the Foundation.
Hi, I'm Bruno. I'm the Principal Architect at the Foundation.
So, as you may or may not know, as John said, the past year we've started building up engineering at the Foundation. So we're here today to talk to you about what we've been cooking. A lot of the things we've been doing at the Foundation is both catching up to pre-existing standards and innovating on top of it. And the first topic is HDwallets. So as you may or may not be familiar, in Algorand we have the concept of one mnemonic, one account, one address. With the adoption of HDwallets, we are trying to shift this mechanism to one mnemonic, multiple accounts, multiple addresses. Bruno, tell us why.
Thanks, Alessandro. So that's absolutely correct. So for the past few years, we've been using the traditional system that we all know, 25 words, meaning the last one being a checksum, and that works fine. But until now, we had 25 word that gives us a single account system. Now, this creates a few problems. As the rest of the entire industry has been using other standards, and for the sake of interoperability, it is important for us to adopt the right standards. So what is proposed here is that we move to a system that complies with what's traditionally known as BIP 39, which defines the 24 words, BIP 32, which defines the derivation scheme, and BIP 44, which specifies the path in which you use BIP 32. The problems that for us to not support these has been some projects have not included Algorand because we have a custom way of importing wallets, creating wallets, and deriving accounts. And now we have implementation that now we can derive several accounts under the same mnemonic and several keys under the same accounts.
Okay, so you've explained brilliantly what HDwallets are, but there's written X HDwallets. So what's going on here?
Yeah, so a little bit of context. So the traditional BIP 32, which defines the derivation scheme, has been widely adopted for the chains and ecosystems that support a specific signature scheme in ECDSA. We use a different scheme, and only until a few years ago, there's been a paper published that some ecosystems have adopted on how to do this safely for EDDSA. And this paper has been around for, I think, around 2 years. It's published, people can read it. Now, as we're doing research within the foundation, we want to do research to improve the ecosystem. We looked at this paper and we decided to partner with Chris Picard. So Chris Picard is a world-class cryptographer. And we together assessed the paper. And with Chris's guidance, we assessed that the paper specifies how to derive these keys. And the keys being related to each other, there are sort of a little bit of bit security loss as you derive these keys. And in Chris's opinion, not that we can prove there is broken, but that bit loss security is not insignificant. And so with Chris's suggestion, we implemented what we call Picard's derivation. And there is a paper on it that Chris wrote and helped us put it together. And there's a link for it. I hope people read it, review it, and we might get it published. That is something that we're discussing. Now, with this scheme, the X stands for this extra security, but also we not only derive keys that we can use for multiple purposes, multiple keys for your Algorand accounts, keys for identity, keys for communication, keys for authentication, and one-time payment addresses. Some project has been screaming for this. We can support this. And one extra, thank you. And one extra feature that, because we implement this according to Chris's paper and the traditional paper, we can safely do what's called elliptic curve Diffie-Hellman between any Algorand address. An address is just an encoding of a traditional public key. We can actually do end-to-end encryption between two Algorand addresses. So the use case is then the possible feature set expands.
Bruno, does this mean that we can actually and finally have safe on-chain messaging?
If you want to implement it, we have 3 implementations at the moment. We have Kotlin, Swift, we have a TypeScript implementation as well. And so this is an invitation for all of us to adopt this scheme and expand the feature set that our wallets and apps can have.
That's amazing. And now that we can have multiple addresses per single mnemonic, we can start to usher in the era of decentralized identity on the Algorand chain. So give us a 2-minute explainer, or even 20-second on decentralized identity. What is it?
I'll need more than 20 seconds. Decentralized identity stands for the fact that, like holding the custody of your keys for your transactions, you can hold the keys that define your identity. It's a bit different than, for example, a member state defining what your identity is and controlling that identifier. We went down the route with some partners like ATech to implement what's called a DID method. A DID method is a W3C standard that is being widely adopted by not just Web3, but the rest of the digital world. And that defines digital identity anchors that are cross-ecosystem. So DIDs are actually identifiers that they can be used across ecosystems that can be verified without having to know what Algorand is. And so it is important to apply these standards so that real-world applications can happen, can be implemented, and also being compliancy-friendly and regulatory-friendly as well.
So by abiding to the DID method, someone can scan and verify your identity and credential without knowing it's backed by the Algorand security?
Yeah, great question. So DIDs stand for decentralized identifier. Your ID is what you present to issuers, for example, and verifiers. Now, on top of the DIDs, there is more standards that define something called verifiable credentials. And this would be the case of somebody issuing a driver's license, for example, issuing a credential proving that you work for the Algorand Foundation, or that you're an ex-gov, or what your university certification is. Those are issued on top of decentralized identifiers, if they adopt these, is being widely adopted. And when presented to prove that you work for, you say you work, or what certification you have, the verifier doesn't need to know what Algorand is, doesn't need to care. Algorand will be used implicitly, because the chain will be read often as any time that you present a credential to be read, they need to verify that you have a digital anchor. And that can be anchored in Algorand. And Algorand will be used implicitly. It will be read a lot more times than is actually written.
This is amazing. Shall we take a look at how it works behind the scenes?
Yes, let's look at that. So there's a lot of DID methods, different implementations. A blockchain is not a hard requirement to comply with this specification. It adds a few features. In Algorand in particular, adds some extra features. So we work with our partners of ATech to design our DID method to be W3C compliant. And so any identity provider, including yourself, you can be your own identity provider. We included this on the design on purpose. But there's many identity providers that use traditional storage systems, IPFS, and other storage mechanisms. We can now store DIDs on Algorand. You deploy a contract. This contract expects you to have publish some metadata around the subject. This is not personal information. This is cryptographic material, verification endpoints, what public keys you use, things like that. And this is stored in boxes. And this is actually, we have an offering for people that are already identity providers that use other DID methods. In Algorand, the cost, arguably, for things like identity that are long-lived can be much smaller than other DID methods. You're not having a recurring cost of infrastructure and pinning services. You do have a cost of collateral of algo, but it's a one-time cost, and if you ever off-board users, you get those costs back. So there is an economic incentive to adopt the DID algo method, even if you don't know about Algorand, and that is value added for somebody that is doing identity, is looking for a cheap, efficient DID method, we have an offering now.
So I see that, is it that given that we're using Algorand, I can become my own identity provider?
Yes, and this will be very interesting if the wallets, if we start having applications that are identity enabled and the wallets start offering this, for example, you could deploy your own contract, so your own identity provider. And if you comply with the spec, any credential issued on your DID will be validated, could be presented anywhere outside of Algorand, interoperable with the rest of the digital world, because there is a piece here called the DID Resolver, which is part of the Decentralized Identity Foundation projects that all projects that adopt these standards will run. And we got accepted, merged, deployed. DID algo is W3C compliant, therefore it can be used anywhere, even outside of Algorand.
So we can finally have self-sovereign identity.
We can, yeah, especially with HDwallets. We can create keys dedicated to the DIDs.
Nice. Speaking of self-sovereignty, as an industry, we spend billions and billions trying to create this perfect, self-healing, long-running, everlasting machines that we call blockchains. Yet, when it comes down to interacting with it, we cave into the middleman. We use things like Wallet Connect. My question is, why? Why are we doing that?
Well, I think we have a new slide. Yes. So this is the one I'm personally more excited about, because for years I've been wanting to tackle this, and I had the right crew in the foundation to try to have an offering to prove that Wallet Connect was a pointless adoption by the Web3 ecosystem. They had first mover advantage, fair enough, but if we want to live by the ethos of decentralization, we're very comfortable in adopting a product and a company to control the flow of information. Even if we can claim some of their infrastructure is open source, they control the protocol. Every time we want to make a change in Algorand, we have a new method, we have to ask permission. We have to whitelist applications in their cloud infrastructure. They have been known to make some decisions regarding some regions in the world due to geopolitical reasons. I don't think we're living by the principle of decentralization. And when it comes to things like identity and payments, the user or the holder and the verifier, the app and the wallet, need and should talk directly. And this is part of some of the specifications going on some of the open working groups, and Wallet Connect does not fit in that model.
Yeah, so today we're happy to announce LiquidAuth, but first, what is LiquidAuth? It's a peer-to-peer authenticated communication system. There is no middleman, and what you're about to see is just a reference implementation. We're not trying to replace Pera or DFly. They're wonderful wallets, and they do a better job than us. But this is just a proof of concept that shows that removing the middleman into peer-to-peer communication is possible. And it is possible, if you look at it, by using standards that are way older than our industry, that compliance departments know. So if we want to bring mass adoption and get the Web2 people on board, we'll have to comply to these standards and don't have middlemen, private companies that can decide to turn off communication whenever they want.
Yes, and while you prep the little gem we have ready, I just want to say that this is one of the aspects of Web3 that, for me, has stifled real adoption, is we haven't signaled maturity from the Web3 space to the big integrators that they can integrate this technology with no or little risk. By us adopting custom standards every time, inventing new standards, instead of looking for interoperability and open standards that in no way stifle the self-sovereignty aspect of our industry, we have introduced risk, and our presentation to these big integrators has shown that we were not ready. And these are small steps HDwallets, digital identity, and LiquidAuth. It is a reference implementation of known standard, open standards and protocols that companies and organizations already use. We're not reinventing the wheel. Hopefully there's a signal of maturity to the big integrators that we're trying to follow suit and make this industry more attractive, and Algorand is taking charge on this.
Let's dive a bit deeper. How does it work? And then maybe we'll do the demo.
Yes. So the first thing we do is the authentication. So there's a lot of conversation about authentication in Algorand. How do I prove to a verifier on an app that I own a specific Algorand address? And in cryptographic terms, the only thing you need to do is to provide a signature. So some ecosystems has gone down the pattern of using the chain to prove that you own a specific public key. Now, you actually don't need to do that. You can't do that. It is friction, it has costs, and quite slow and not standard compliant. The only thing you need is a signature. So we actually use FIDO, traditional passkeys, WebAuthn, to do authentication to prove ownership of specific keys. And how we do it, we actually do two sets of proofs, two separate signatures. In FIDO, you have to use a signature that is bound to the HSM that lives in your hardware. It's a hardware-backed key. And then you have another proof, another signature of your Algorand address. So when an Algorand app gets an authentication request from a wallet, it knows that you own that Algorand address because you have a signature for it, and plus the signature of your device in a hardware-backed key. Once that's done, we want to do peer-to-peer comms. So we use WebRTC, but before we can establish peer-to-peer comms, we want to use a set of already established, known in many other industries. To find each other's IP, you have to do, it's called NAT transversal, to route on internal networks linked to some public IPs. It gets a bit technical, but you need to find each other's public IP and then route those to the actual devices. We take care of that. Once that's done, those components go away, and then you do peer-to-peer comms with WebRTC between the app and the wallet, the holder and the verifier. There's no middleman. You talk directly who you want to talk to, and there is nobody controlling the flow of information. You and your peer are the only ones in that channel.
Shall we take this for a spin?
Let's go. There's this thing called demo curse.
So this is not like ChatGPT 4. This is my actual phone. As you can see, this is not fake. So this is a demo dApp that is, let's say, for Algorand. If I click on connect, there is a QR code that appears. We went with QR code. I open up LiquidAuth, and they simply scan it. Here, you can't see it because Android security feature. Here, my phone is prompting me for my fingerprint. It's happy about it, and we have established peer-to-peer connection. Let's try sending a transaction.
That's it.
It's testnet, unfortunately. Here, as you can see, there is another payment transaction request. I need to authenticate with my fingerprint.
Passkeys authentication, goes peer-to-peer, response, submitted.
It's submitted,
yeah, no
and transaction is confirmed. And as you can see here from Pera Testnet Explorer, final, instantly final, submitted in less than 3 seconds.
Shocker.
Thank you, Algorand. But of course, why are we going through the hops and hurdles of using adopted standards? Well, because by using adopted standards that the web uses, all of a sudden, wallets can start thinking of becoming lifestyle applications. In my example, I mean, I continue to forget passwords, so I've completely bought into the passkey environment. And let's try and sign in with GitHub.
I don't believe you. Show me.
I don't want the 1Password passkey. I don't like it. I want to use my phone. Here, as you can see, I can have it on Google or on LiquidAuth. This is weird. Let me click LiquidAuth. Connecting.
Demo curse.
This is conference Wi-Fi.
And a demo never works.
Let's see if... All right.
Try
it
one
is a
more
demo
time.
after all.
Otherwise, you have to believe us.
Let's try again. OK, now it crashes, and now it will work. Perfect. It takes a second. It's still in alpha.
Swear we tried this for a week and never failed, and we knew that on a demo it would fail.
At the end of it, tech demos, live on stage, what can you think of it? And I'll click continue. I need to authenticate.
Shocking.
And I'm connected with GitHub.
Very good.
As simple as that. I mean, a few hoops too many.
Now, just one thing to this. So, since Android 14, Google actually opened the APIs for us to allow to do this, so your passkey is not attached to your Google account. Now, what we can do with HDwallets, we can actually start recovering the keys that are linked to our authentication and do this in several devices. So it's a great example of adopting these.
By the way, v2.1 of Booyah compiler has boxes support. We'll talk about that this afternoon. But if you like what you see, we at the foundation surely think that the future is liquid. It's a proof of concept. There will be many new features that we want to implement. And this is a call to action for the entire ecosystem. If you like what you see, if you want to contribute to it, PRs are always welcome. The repos are open. We're happy to collaborate. And yeah.
Yeah, and LiquidAuth is really an invitation to follow the vision of adopting the right standards that we need for compliance, regulatory friendliness, and interoperability. And we need help, so if you share the vision, we need apps and wallets to go on a journey. It's agnostic to the context, so if you're building payment applications, identity applications, and so on, feel free. We need iOS app and contributions.
And I just want to add one thing. You know, we've got a wonderful engineer at the foundation who works on Bruno's team.
Michael Fairhair.
Michael Fairhair, and he's written so much of this code. Just want to shout it out. Also, what you just seen, yeah, signing into GitHub, signing into Apple, signing into websites to take passkeys, that's cool with your Algorand wallet. Better than ZK Auth, clearly. But what's even more important was earlier, when we were talking and sending transactions with that dummy dApp, we're doing that without Wallet Connect. That's a peer-to-peer connection, maintaining the entire thesis of why we do this type of thing. So, I think I can speak for us all when I say, fuck Wallet Connect.
Yes.
Thank you, everyone.
And Mike, you're a king. And, well, thank you
more.
all very much.
Oh, thank you.